Let's try to find the velocity at a single point in time. Let's try exactly 3 seconds. We need a new trick since slopes, which are velocities, need 2 points. But if I choose 2 points, I am finding an average between the points. So we're going to do a little bit of a math trick to figure out how we can take the slope of a line, or excuse me, the slope of a curve at a single solitary point. So here is our point. If we drew, let's say, an interval like this, and connected that interval with a line, it would approximate what this curve looks like in this region. It's almost a straight line, but it isn't. So we would be taking an average. What if I shrunk it further? Oh, much closer to what the shape looks like there is a line, but still an average and not a line. In fact, no matter how much I shrink it, I will be getting closer and closer to a line in that interval, but it will never mathematically be a line. So the question is, how far do I shrink it? This is a weird math thing. I'm going to pretend a point actually takes up space. I am going to draw a line that, if a point had space, would connect both sides of that point. Kind of weird. What this is really doing is finding a tangent line. A tangent is basically, the idea is you're connecting both sides of a point. This line brushes up along the curve, following the shape of the curve at that point. It never crosses the curve, since every point must have a unique tangent, and I can draw an infinite number of lines that would cross the curve at a point. Plus, crossing would probably not follow the shape of the curve. So I need to find a tangent line. So what am I going to do? Here's how we can find our tangent. Here's our point. A tangent line might look like this. Okay, it won't be perfect, but let's give it a try. A tangent line kind of looks like this. Definitely not perfect, but you get the idea. I tried to make it run along the curve. So what happens when I find the tangent? By definition, the slope of the tangent is the slope of the curve at that point. So what have I done? I shrunk the interval that I was looking at so it was infinitesimally small. All right, both sides of a point, which doesn't exist. And then I'm simply going to take the slope of the tangent line. So pick 2 points on the line. Once again, we won't be perfect. Not a lot of straight edges, but this is okay. And I'm just going to find the slope of that line. Well, let's see what we have. Oh, about 36 meters minus 0 meters over 4 seconds minus 1.4 seconds. So we have 36 meters over 2.60 seconds, and that gives us about 13.8 meters per second. And that is the velocity at 3 seconds.